Hello again, students. This is Miss Dutton, and this time we'll be looking at SOL G6 Part B. And Part B, pull this back across here. Part B is looking at proving two triangles congruent using coordinate methods. Coordinate methods, which means we're going to be graphing some here. Now, I really don't have a exact way I do these problems. I'm more of a visual person, so I've got my pencil ready to graph and erase if I need to. On the SOL, you of course have a drawing tool, or you can request graph paper and draw them out yourself. So let's take a look at the graphs here and what we're being asked to do. For each of these, we're asked to identify the coordinates of a point that would create two congruent triangles. Okay, so let's take a look at the first example here. It says identify the coordinates of point F so that triangle ABC is congruent to triangle DEF. So when I look at the congruence pattern here, the congruence statement, I need to know what two parts are congruent. So I've got side AB that's 3 units long, has to match up with side DE, which is also pre-graphed and is 3 units long. All right, so next I could check out side BC. Side BC is the longest side of this triangle, which means side EF, wherever F is, has to be the longest side on this triangle. Also, I've got to match up AC, which is the medium length side, to DE, DF, which should come out to be the medium length side. So here's some things that I noticed. Here I'm working A, B, C. So I'm going from A, I'm going up 3 and then down to C, versus DE, F, DE, I'm going down. So A to B goes up, but D to E goes down. So I think my triangle has been flipped upside down, okay? So when I go to find point F, I think it's going to be somewhere up in here, okay? Or maybe over here. It's going to be up above point D. So A goes up to B and B goes down to C, but D goes down, so it's going to need to come back up. Okay, hope that was a pretty good explanation. Let's see what we can do. I'm going to go from A to C. From A to C, I need to go down 3 and right 3. Okay, down 3, right 3. Now, A matches up with D, so I need to work from point D. If I go down 3, right 3, there's no way I'm going to form a congruent triangle. I need to go up 3, right 3, or maybe up 3, left 3. We don't know. It's a wide open question. But by following the same pattern it took to get from A to C on this triangle, I'm going to be able to form a congruent triangle, and I don't know which direction it's going to be facing. So I actually get 2 possibilities of where to put point F. Let's check out and make sure everything's a match. From A to C, so the first to the third letter, is a rise of 3, a run of 3. So from D to our point F would be a rise of 3, a run of 3, or over here also a rise of 3, a run of 3. Let's check from B to C. From B to C, it looks like a rise of 1, 2, 3, 4, 5, 6, and a run of 3. A rise of 6, a run of 3. So come over here to our longest side. A rise of 6 and a run of 3 gets me to this point F, and a rise of 6 and a run of 3 gets me to this point F. So I think I found my 2 locations of F that created these congruent triangles. I've got one at 1, 4, Or I've got another possibility at -5, 4. Just want to make sure that everything's a match so that the congruence statement works out. It was a pretty tough one. Triangle has been rotated or flipped or something, but we found its possible location of F. All right, let's move on to the second example. This one's a little easier, but you really got to understand the congruence statement here. We've got triangle ABC, which is pre-graphed, needs to be congruent to triangle CAD. Well, check it out. C, C, A, A. So there's only 1 point difference. So these triangles have to be connected somehow. And it looks like since A and C are used in both triangles, that AC is going to be a shared side. We've seen that shared side before. AC is going to be a shared side. So that means there's only one point to plot, and it's going to be point D out here somewhere to make these two congruent. Now, BC, that's the easiest one to work on. It's a vertical piece. It's 4 units long. And BC has to be congruent to DA. So B down to C. I have to go down to get to C. So D to A, okay, looks like it's going to be a flip. So I'm going to go from A down 4 to find the point D. See if that made a congruent triangle. All right, well, up 4, up 4. That's a match. To get from B to A, I'd go up 1, rise 1, run 4. That's B to A. So from C to D, I need to go rise 1, run 4. Check. To go from A to C is going to be the same as C to A, so that part's taken care of. This D was easy to find. I need to go name the point, over 2, up 1, location of D, the point 2, 1. Okay, one more example to walk through with you here. Identify the coordinates of point D so that ABC is congruent to DEF. It looks like we have two totally separate triangles. None of the letters have been repeated, so these two triangles are totally separate of each other. So we've got ABC congruent to DEF, and EF has already been graphed. Well, EF matches up with BC. BC is 4 units long. EF is 4 units long. So that's a match. So we have to somewhere find D to make a congruent triangle. All right, well, I'm going to work from B to A. That's a rise of 1, 2, 3, 4, 5, and a run of 1. Rise 5, run 1, going from B to A. So B matches up with E. I need to follow the same pattern to get from E to D. Rise 5, run 1. Okay, let's check out A to C. This would be a rise of 1, 2, 3, 4, 5, a run of 3. 1, 2, 3, 4, 5, and a run of 3. I think we have a match. D is in a good location to create a congruent triangle. That's the point -2, +2. But there's nothing that says D has to be in the same orientation. Why can't point D be flipped over? Why can't the triangle be upside down? Well, if the triangle was upside down, let's use some reflection here. Here's my line that I'm going to reflect across, EF, which is already graphed for me. D is 5 points above that line. So what if I flip it to be 5 points below that line? Does that still create a congruent triangle? Let's look, a visual inspection here. Okay, do we keep the same rise over run? Well, B to A was a rise of 5, a run of 1. So D to E, rise 5, run 1. That's good. A to C was a rise of 5, a run of 3. So D to F is a rise of 5 and a run of 3. So we've got 2 locations that point D could be. This is the point -2, -8. Reflections, translations, rotations, they're all going to really help you here. Anything that's involved with graphing, you can use a lot of your transformational approaches to find the coordinates that you need. Really pay attention to these different congruent statements. They're going to help you organize where the points should be, and then just use those eyes, find the congruent spots. Hope this video has been helpful. Come on back for proofs, part C.